Hi guys, in this video I'm going to talk about some of the frequently asked network interview questions related to DNS, that is the domain name system. This video is a part of a playlist in which I have uploaded many videos about network interview questions concentrated mainly on the network basics. So this video we will mainly focus on domain name system and what are the frequently asked interview questions related to that. I have listed out some of the questions. Like I have like 8 questions which I'm going to talk about, about a domain name system in this video. Like what is DNS, how it works, or it can be simply asked like what happens when you type www.google.com in the browser, or how the local DNS server selects a particular root server, and what is a recursive DNS query and a iterative DNS query, what is the DNS port number, and whether DNS uses UDP or a TCP protocol, and how to view the list of DNS servers responding to our DNS queries. That is from your local machine. How can you see the list of DNS servers that are responding to your queries, and how to flush your DNS queries from your machine, and how to check which root server responding to your query, etc. So first we will see what is DNS and how it works theoretically, and then we will see a practical demo in a Cisco Packet Tracer as well, like how I demonstrated in my previous videos. Basically, when a user types, let's say www.google.com in the browser, the system needs the exact IP address of the domain www.google.com, right? So DNS is something resolves an IP address to your domain name. So in the coming slides, I will explain how it works, and basically most of the time in the interview, they will simply ask what happens when you type www.google.com in the browser. So it's a huge process. I will explain step by step. Let's say when the user first types www.google.com in the in the PC, the PC first will check in the browser cache whether is there any resolution for google.com to any IP address to which it can send the HTTP request. If it is not there, it will check in the local system, the system etc/host file. Is there any entry for www.google.com getting resolved or not? If nothing found in the local PC, then the PC1 will reach out to the local DNS server. If you look at the IP address configuration of any machine, you can see we would have configured DNS server IP address. So that locally configured DNS server IP address, the PC will send a DNS query like what is an IP address of www.google.com. Now the local DNS server receives that. It will check in the local DNS server cache file. If there is a entry for www.google.com to reach that, what is the domain IP address, it will send a DNS query response back to the PC1. In case if local DNS server doesn't have that entry for www.google.com in this cache file, it will send a DNS query message to the DNS root server. Now the local DNS server will send a request to your root DNS server, like what is the IP address of www.google.com. So the root DNS server, there are some main 13 root DNS server globally. It will respond back like I don't know, but you can check like 43.12.4.1, whatever the IP address of a TLD name server. The TLD name server is nothing but the top level name server. It's a top level domain name server. That is what we call as TLD name server. You can simply take it as like for each .com or .org or .net, there will be a top level domain name server. So the root DNS server looking at that full domain name like www.google.com, it will send you can reach out to that particular corresponding TLD name server, which can help you out in this query. Now, local DNS server receives that information about the TLD name server, and it will send another DNS query like what is the IP address of www.google.com to the TLD name server. So this top level domain name server will send a reply back saying that it doesn't know the exact IP address of the domain www.google.com, but it can refer to the authoritative name server for that www.google.com. So that IP information, the TLD name server will send to the local DNS server. So the local DNS server receives that information. It will send again another DNS query to the authoritative name server about what is the IP address of www.google.com. So this authoritative name server is, will respond back with the exact IP address of the fully qualified domain, that is www.google.com. So authoritative name server will respond back to your local DNS server to reach www.google.com. The exact IP is 172.217.31.196. So the local DNS server will store this information in this local cache, so that in case if the PC2 sends a DNS query, it won't do all this DNS request to root DNS or TLD, something like that. It will directly respond back to the PC2 that to reach www.google.com, you have to reach this IP. So this is something local cache time. By default, I believe it will be like 24 hours. It will be stored until it gets flushed out. So the local DNS server send this information to PC1, that is to reach www.google.com. The IP address is 172.217.31.196. Now this PC will know the exact IP to reach google.com is 172.217.31 and 196, and it will initiate the HTTP request directly to that IP address. So this is the flow how the DNS query and respond works in real time, and I'll just quickly recap that. Like the PC1 sends a DNS query request to the locally configured DNS server or a resolver, and the resolver will reach out to the root DNS server. The root DNS server will refer the TLD name server. The local DNS server again reach out to this TLD name server. The TLD name server resolves the authoritative name server, and the local DNS reaches to this authoritative name server. The authoritative name server definitely will have the exact IP of the fully qualified domain which we are trying for resolve. And once that information received in the local DNS server, it will pass it to the PC, and after that, any request coming for the same domain name, the local DNS server will respond to that. Now coming back to our questions, like how the local DNS server selects a particular root server. So if you look at the ina.org, there are 13 root server which are normally configured in the DNS root zone. So the local DNS server will reach out to any of these configured root server, and the selection is round robin. Like the first request goes to the first root server, the second request goes to the second one. So like that, the selection is in a round robin manner. So from the list of root server, the local DNS server selects in a round robin manner only. And the other question is like, what is the recursive DNS query and what is the iterative DNS query? First, let's see what is the recursive DNS query. The DNS query that is from PC to the local DNS server is called as a recursive query because the local DNS holds the responsibility to resolve the fully qualified domain to an IP address. And the DNS query is coming from initiated from that local DNS server to the root DNS servers, and between this TLD name server and the local DNS server is called the the iterative DNS query. Because these server, if they don't know the IP address of the exact URL, they simply refer to the another DNS server IP address. So the recursive query is between your PC to the local DNS server, and the iterative DNS query is between your local DNS server and between the the DNS root DNS and the TLD name servers. Okay, now the next question is like, what is the DNS port number, and whether it uses the TCP or UDP protocol. Well, DNS uses the well-known port number 53. I will show that in the Cisco Packet Tracer after this discussion. And regarding the protocol, UDP or TCP, the DNS uses TCP for zone transfer and UDP for name resolution and queries. Basically, the UDP is used to exchange a small information, whereas TCP must be used to exchange information larger than 512 bytes. If a client doesn't get response from DNS, that is a PC, it must retransmit the data using TCP after 3 to 4 seconds of interval. Or in a simple time, you can say, normally it uses the UDP, but if the size is bigger than 512, it uses TCP. Now, regarding the questions like, how to view the list of DNS servers responding to our DNS queries, how to flush the DNS queries, how to display the DNS queries, how to check which root server responding to your query, I will show from the laptop command prompt. So this is my local machine, and the command to check the list of DNS entries is to give IP config space / display DNS. It will show all the DNS entries here. These are entries for the Google. So you will see a huge list in this one. So now I'm going to clear all these DNS entries. IP config space / flash DNS. So successfully flushed the DNS resolver cache in this PC now. Now if we give the same command IP config / display DNS, there is no entries now. So unless until we initiate any request to any of the domain, we won't see anything in this. Now let me initiate a ping to a one website like www.miniclip.com. So I got a reply. So definitely that would have been a DNS entry for, let's see, IP config space / display DNS. So these are the entries. You can see the actual IP address for this website www.miniclip.com is this 13.249.208.126, which you see here, the actual IP address in the end we got. And before that, you can see the multiple entries of the DNS servers that is responding for this. We can also do this NS lookup in Windows. w.miniclip.com. It will give you all the DNS details, which DNS resolving this IP address for this domain. Let me clear this one more time. That is with IP config flush DNS, and let me do a ping to bbc.com. So now I'm going to check the DNS display command, and you can see the host area record for all this bbc.com website. So basically the NS lookup and display DNS will list out um, the IPs of bbc.com and which DNS servers and a record for that particular host name. So with this command we can find which DNS servers responding, to get the actual, IP for this domain bbc.com. So these are Windows command. I think in Linux you need to use the dig command to find the uh, domain name to host resolution and the DNS responding for that. Now I'm going to go inside this PC2. The IP config, you can see the PC2 IP address is 192.168.0.11 and the DNS server configured is 192.168.0.240, which is nothing but this local DNS server IP address. Now I'm gonna open a website. I'm going inside the browser. I'm gonna type the website name sirokumarnetlabs.com. So I'm going to give go. The moment I give this, we can see first a DNS packet is generated and immediately ARP is generated because the DNS request from the PC2. I mean, when you type that URL in the browser, the PC2 checks in its local cache. If it is not there, it will reach out to the local DNS server configured. The local DNS configured is this local DNS server 192.168.0.240. We'll open up this DNS query packet first and we will see. So the DNS client sends a DNS query to the DNS server, which is nothing but 192.168.0.240, which we statically configured. So other packets, you can see it is a ARP request because we don't know the ARP entry for this destination IP 0.240. And you can see this ARP request is not going to your let's open this packet and see. So this is the IP header. Source IP is 192.168.0.11. That is the PC IP. Destination IP is 0.240. That is the DNS server. And under the UDP header, you can see the destination port 53. So DNS uses the port 53. So that's why the destination port is given as 53 here. And this is a DNS query message. And the query is for the domain name sivakumarnetlabs.com. So this is the DNS packet format. So since we don't know what is the MAC address for 0.240, which is in the same subnet, we are sending a ARP request directly for that IP address. We will see the ARP packet also. The ARP packet constructs a request for the target IP, that is 0.240. It directly encapsulates the frame and it's sending out. And one thing to notice here is this is directly sending to that IP 240 because the PC2, that is 192.168.0.11, it's in the same subnet of 240. So it is not sending the packet to the default gateway, which is your router IP, and it is directly sending to the destination IP. In my first video about basic packet walk, the destination IP is in a different subnet. So the ARP request first goes to the default gateway and then ICMP request goes. In this case, it's different. Let's play this packet. Give nest. You can see the ARP request goes to the switch, and then it's a broadcast packet. ARP request is a broadcast packet, so it goes to the router, the PC, and the local DNS server. All the connected ports in the switch except the one it received. So the local DNS server receives it, it sends the ARP reply, the PC2 gets the ARP reply. Now again, you can see the DNS requests being sent out. You can say again, this is the DNS query. Now we know the exact destination MAC address of this local DNS server. So we are sending the DNS query. So the DNS query going only to the local DNS server. So now the DNS server responding back. Now let's see, this is the DNS response message. You can see the source is 192.168.0.240, destination is 192.168.0.11, the PC2 IP, and destination port again. Sorry, here the source port is 53 because the DNS server is responding. So the source port will be 53, destination port is 1030, and you can see the DNS answer. The DNS query is the name sivakumarnetlabs.com needs to be resolved, and the DNS answer you can see for this particular name, the IP address is 192.16.10.81. That is nothing but this web server IP address where the website is hosted. So this is how you will get the DNS query response. Now you can see the PC2 receives it. You can see the moment the PC2 receives it, the PC2 generates a TCP packet. We'll open this up and see. So this is the TCP packet. The HTTP client, which is your PC, makes a connection to the server. And this is a TCP sync packet to the destination 172.16.10.81 on the port 80. You can see the IP. The source is 0.11, and the PC knows the exact IP address of the website, the domain name, IP address. So it is directly sending this request. A source port, random port, and destination port 80 for HTTP. This is a TCP sync packet. So in this example, the local DNS server is able to resolve the IP address for this website sivakumarnetlabs.com. In case the local DNS server don't have the IP detail for this domain, the local DNS server will send a DNS query to the root servers, and then TLD name servers and the authority name server. Once it gets, it will send the reply back. Now it is initiating ARP because the destination IP, which is that HTTP server IP 172 segment, it's a different subnet. So it has to resolve that IP. I mean, to send the IP to that destination, it has to send the packet to the default gateway. The default gateway MAC is not yet learned, so it is sending ARP request to the router, the default gateway IP address. If you open up this ARP packet, you can see it is sending ARP request to the destination IP 192.168.0.1, and it's a broadcast packet. Let's see. So the switch is forwarding to everyone since it's a broadcast, and only the router one will respond back with its MAC address. So PC2 receives it. Now PC2 sends the TCP packet, the HTTP packet to router 1. Router 1 already have the IP reachability to the server, so it is forwarding to the switch, and it goes to the HTTP server. So the server is responding back. This will be a SYNAC packet. Let's open that and see. Okay, here it is resolving the ARP. Actually, you can see here between this router and the HTTP server, ARP resolution is happening. Basically, the person taking interview asks about to explain all these basic detail about ARP resolution, about basic packet forwarding. We have to explain this as well, like each segment, how the ARP planning process happening and how the routing lookup happening on the router, all those information. The same details which I explained in my first video in this playlist about basic packet walk. So now this is a TCP packet coming from the HTTP server, and this should be the TCP SYNAC packet. Let me open up and see this. Okay, yeah, this you can see this is a acknowledgement number 1. So this is basically a SYNAC packet for the TCP sync packet which we sent earlier from the PC2. So router sends it to PC2. The moment PC2 sends this, it will initiate a HTTP request. You can see the moment it receives the TCP SYNAC packet, you can see a HTTP sends a HTTP GET request packet basically. Let's open up and see this one. So you can see this is a TCP packet, source PC IP, destination server IP, and destination port 80. And you can see, so HTTP request. So this is the request packet. Now that goes to your switch goes to the router. And you can see there is a TCP three-way handshake getting completed. This TCP packet is nothing but your ACK packet for your SYNAC. And then HTTP gets that. Now this is a HTTP response packet. You can see in this. You can see this is a HTTP response. Okay. Now PC receives that. And then when I open, you can see. So now when I open http://sivakumarnetlabs.com, you can see the HTML index page that I created, like welcome to Sivakumar Netlabs YouTube channel. This channel is for the network engineers. Now let me stop this real time and go to this PC and browser. Let me open now in real time. You can see the page immediately opening, and also let's see the command prompt. So this is the PC2 command prompt, and let's see the ARP entry. You can see the ARP entry for the gateway and also for the DNS server, and DNS lookup for Sivakumar netlabs.com. You can see the DNS server which is resolving for us. You can see that entry DNS server IP address and also the actual IP address of the particular domain that we are trying to open up. So now going back to the question, like what happens when you open a website from your PC? In a new environment where there is no IP ARP landing happened. So this is how basically we have to explain from the beginning, like starting from the ARP landing, routing lookup, how the DNS query getting resolved. After the DNS query, how the HTTP request and response getting completed. So basically, it's a very lengthy explanation, and most of the time I have seen this question is asked to understand the basic networking skills of a network engineer. And again, Cisco Packet Tracer is a very powerful tool if you want to um, understand the concepts very clearly in a detailed manner. I would recommend you guys to practice this in your laptop installing the Cisco Packet Tracer. And so with this, I have covered all the possible questions that can be asked related to DNS. So we have seen how to flush the DNS queries. We have seen how to list the DNS server responding for our DNS queries, right? Thanks for watching the video, and don't forget to subscribe to this channel and hit the bell button so that when I upload a new video, you'll get an alert. Also share this playlist about network interviews with your friends, anyone preparing for interview, this will be really useful.